Hi, ladies and gentlemen, this is Mr. Green again, and this is another in my series of recordings for the pre-cal course. And I just want to make certain you all are aware where we're at. Every 28 days, or every Monday, I'm closing more and more lessons. And when I close them, it's because they've been open for more than 28 days and they have passed their due dates for 28 days. And once they're closed, you can't go back and make them up. So you want to make certain you're getting things made up before they get to that 28-day mark. Okay? We're working our way through Unit 4. We've got a couple more lessons we're going to do, and then we'll be wrapping up Unit 4 and into Unit 5, which is the last unit of the pre-cal course for the first semester. So we're getting close to the end, just keeping you aware of where we're at in the lessons. Now, back in Unit 1, we studied arithmetic sequences. You can look at these. This one here, it says 14, 18, 22, 26. If you look at this real closely, you notice the difference between 18 and 14 is 4, and 22 and 18 is 4, and 26 and 22 is 4. The difference is always 4. The first term happens to be 14, and so we came up with a formula that told us if we took a sub n, which is the nth term in the sequence, that was equal to the first term in the sequence plus r, that 2, or that 4, times n minus 1. You know, that looks very similar to the linear equation, y equals mx plus b. And that's because it is the linear equation. That is what linear equations are, is a sequence. Okay? Now, if we're looking at a linear equation, we're looking at a line. If we're looking at a sequence, we're looking at a series of points. And the difference there is we're just looking at points in a sequence, not the entire infinite line. Okay? But where it does look very similar, where b is that first a1 term and r is that m is the slope, okay? R is the slope and y is the term that we're looking for. So it does work out to be very similar to that linear equation. Well, what we're taking up this time is a geometric sequence. And I'm going to start with the same 14 that I did last time, but instead of 14, the next term is going to be 28, and then 56, and then 112. If you look at these real closely, you take 28 divided by 14 to find that difference term, and you're seeing that it is 2. And if you take 56 divided by 28, you get 2. And if you take 112 divided by 56, you get 2. So it has a constant multiple of 2. That's the definition of a geometric sequence. It's where it's constantly being multiplied by the same number, and it's growing that way. Okay? So if it's constant multiple of 2, we've got a first term of 14. We can come up with an equation. Well, what we're going to do is I want to try to solve for the equation. So what I'm going to do is I'm going to say 112 is equal to 14 times 2 raised to some power. And I'm saying n minus 1. Well, why n minus 1? Well, if I take 112 and divided it by 14, I would get 8. And that's 2 to the third power. So my fourth term uses 2 to the third power. So n minus 1. So that becomes what the geometric sequence looks like. It's that first term, a to the first, times, oops, that's the sum. It's that first term, a to the first, a1, times 2 raised to the nth power. That's the nth term that we're talking about there. Okay? Let me get my pen working here for just a second. Come on, pens. Work with me. So write that out, Charles. A sub n is going to be equal to a sub 1, and we're going to take the r term, whatever that r is, and raise it to the n minus 1 power. Okay? That's how we find the nth term, whatever the nth term is. So if I wanted to find the 15th term in this particular sequence that we're talking about right here, a sub 15 would be equal to 14 times 2 raised to the 14th power. Now, I cannot do 2 to the 14th power in my head. I have to use a calculator. 2 raised to the 14th power is 16,384. times 14 gives me that my 15th term would be 229,376. 376. That's a huge number, but it's a geometric sequence. They grow very, 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 very fast. A couple of good examples in the lessons, so make certain you're reading those lessons. One of the questions comes up is we could add up the linear ones. We could add up the arithmetic sequence ones. Can we add up the geometric ones? Why? Yes, we can. And there's a derived formula for the sum of terms, and the lesson does an excellent job of showing you how this is derived and how you wind up with this formula. But this is the formula that you come up with. You say a sub 1 times 1 minus r to the nth divided by 1 minus r. So let's go back and look at this one right here. If we wanted to add up the first four terms of this particular sequence that we have right there. Okay, well, my a sub 1 was 14. My r was 2. And we were wanting to add up the first four terms. We just got to plug it into this formula. We say that 14 times 1 minus 2 to the fourth power divided by 1 minus 2. Okay, well, 2 to the fourth power is 2, 4, 8, 16. So I get 14 times negative 15, because this was 16. 1 minus 16 is negative 15, divided by negative 1. Well, the negatives cancel each other out, and I'll have 14 times 15. Okay, 14 times 15 is 210. Okay, well, let's just back up here a second and add these numbers up. 14 plus 28 plus 56 plus 112, and I wind up with 210. Voila, the formula works. We can make that work for us. Okay, so that's a good way of doing it. But there's a different way. You can use the calculator. Using the formula for the nth term, that's what this nth term is right here, I can make it work on the calculator. So I'm going to go back to my calculator here, and I'm going to show you. I keyed in the summation from 1. Oops, that's one of the ones that's in the book. There's one in the book where they're taking the summation of the first 24 terms of a particular situation. And it was 2 raised to the n minus 1. First 24 terms, it got this number right there. And I'm just showing you I could do that on the calculator. But let's do the one that we have here. So I'm going to press Math. I'm going to press 0, because I want it to be the summation. And I'm going to say variable 1, and I'm going to press this forward button so that it goes forward to there, 4, because I was taking the summation of the first four terms, and it was 2 to the, oops, wait a second, it was 14 times 2 raised to the variable minus 1, x minus 1. Okay? And so you press enter, it goes through and thinks about it, and it comes up with 210. Okay? Now I've given you the key sequence here to actually add up the first 24 terms. This is the one that's in the book. First 24 terms, and it has a r of 2. Okay? And so I've added up the first 24 terms of something that had the r of 2. And it was a situation where someone tells a secret to someone, they tell it to two people, an hour later they tell it to two people, an hour later they tell it to two people. After 24 hours, how many people know? And that's where we came up with that 116,000 people number. So it adds up very, 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 very quickly. Okay? Now the book goes on, and it's starting to introduce some calculus topics to you. Okay? One of the calculus topics it introduces to you is Zeenek's paradox. And this is one where, if Achilles was going to race a turtle, but the turtle's so much slower, so he's going to give the turtle a half the distance head start. If he doesn't get started until he's gone half the distance, then, you know, he goes, well, what if I only started at, he goes half the distance and I go a fourth, and he goes a fourth the distance, I go an eighth. Well, if he goes an eighth distance, I go a sixth. You wind up never starting. It's what it amounts to if you let it go on for an infinite situation. And that was Zeno's paradox. They do a much better job of explaining it in the lesson. Please read it in the lesson. But after you've read that Zeno's paradox and you understand it, look for some things on the internet. See if you can come up with a better way of explaining it, because obviously I can't explain it very well. But the whole concept there is they're introducing the concept that if you've got a infinite series, but I've got something less than 1, I can actually take the sum of that infinite series because it very quickly approaches a single number. Okay? Oops, I should have spelled that right. Sorry. So there is a formula. If you're trying to find an infinite series, if r is less than 1, you can take the first term in the series, divide it by 1 minus r, and you will get the sum of an infinite series. I think the example they use is they had a cake. And in their cake, it had, a nice little cake. And they ate half of the cake. And then an hour later, they came back and ate half of what was left. The next time they came back and ate half of what was left. Next time they came back and ate half of what was left. And so forth and so on. Our a sub 1 in that situation is 1 half. And our r is also 1 half. Okay? Because they're coming back and eating half of it every single time. And so if you take this as a formula, 1 half divided by 1 minus 1 half is 1 half. You wind up with a 1. And guess what? In an infinite series of eating a cake like that, there's only one cake. And so it has to add up to 1. And that's the way this formula works. And it works every time. It's so neat. Okay? And what you're getting is an introduction to some concepts and the history behind calculus. Why they developed it, how they developed it. You're getting to see how it came about. Okay? So, having said that, that's all I've got for you today. If you have any questions, make certain you're coming to Toga. Make certain you're watching the Class Connects, because all those things will help you. Okay? And I'm available to you if you have some questions and you want to get some answers. Contact me. We'll see how far we get. Okay, it's good talking to you, and I'll see you next class.